Hello, my name is Nicholas Luxak, and today I'll be outlining how I updated BCPy2000 to Python 3. So before I get into BCPy2000, I think it's important that I talk about the platform that it's hosted on and interfaces with. So BCPy2000 is an open source general purpose development platform hosted by the National Center of Adaptive Neurotechnologies and is used by over 300 labs around the world. So it consists of three modules: the signal source, which acquires brain signals with a wide variety of amplifiers and BCI hardware; the signal processing, which is responsible for the feature extraction and translation; and the application, which is usually some kind of audiovisual stimulus. And then the operator interfaces with all three independent modules and establishes the system configuration for data storage, source variables, and application visualizations. Because BCPy2000 is a fully modular application, we can mix and match what we want to do with each module. So for example, we can use the same signal processing and application for different amplifiers. This is what makes BCPy such an effective platform for us, because we can build platforms which allow for collaborators to do the same experiments among groups with different equipment. So now I'm going to go over the structure of what BCPy2000 is. So our underlying structure is the C++ framework, and here you'll see the signal source, signal processing, and application as outlined in the previous slide. And then on top of that, interfacing with that framework, is the Python framework. This is where we tell Python how to interact with the different protocols that C++ BCPy2000 establishes. And on top of all of that are our developers' Python implementations, and basically what allow us to use the BCPy2000 framework without having to understand C++. So you might wonder why I use Python code, and really it's a simple answer. Here in C++ you'll see an implementation of a simple input and then an output of text. A lot of this stuff to someone who isn't a programmer can be intimidating. We see, our main function in returning a number, when in reality our functionality is that we want to output a string. And here's the same implementation in Python. It's almost intuitive. Another reason why we want to implement BCPy2000 with Python is the increasing popularity of Python. So this is the TIOBE programming index. It's not a measurement of the most used programming languages or the languages with the most lines of code. Instead, it defines its rating by counting the number of hits of the most popular search engines. The search query that is used includes whatever the query the user has and then the name of the language. So this gives us a rough idea of the trend away from languages like Java and C++ and towards Python. And this is important because as we grow as a platform, we want to include as many programmers as possible. In order to understand why we need to update to Python 3 and why this is going to be a long-term project with potentially decades worth of funding opportunities, I'm going to go over the life cycle of Python. First, we have Python 2.7, which was the last version of Python 2 and therefore had the longest life cycle of any Python version. This was a good place to stop development for BCPy2000 because it only stopped being supported on January 1st, 2020. So nothing really needed to change in the code that Jeremy Hill put out in 2007 because we could run it on Python 2.7. Next we have Python 3.6.8, which was the last version which officially supported a portable Python package. This is where Marcus Adamek took up the task of updating BCPy2000 a few years ago, and this is our current version for the 32-bit version of BCPy2000. Then we have Python 3.8, which is set to expire in October of 2024. This is where our current 64-bit portable Python package is based on. And if you'll notice, everything except the final release of a Python version like 2.7 has about a 5-year support cycle. Finally, we'll move on to the latest version of Python, Python 3.9, which is set to expire in October of 2025. And you may be asking yourself why we didn't just update everything to the latest version of Python and not have to touch it for the next 5 years. Well, unfortunately, it takes a bit of time for each of our dependencies, like our stimulus visualizer CyclePy, to catch up with the latest version of Python, so we have to wait at least until everyone else is updated before we can update our own implementation. Another reason why we want to use Python is because it offers us a large library of standards and toolkits and packages, more so than almost any other language. As of right now, the largest repository of packages, PyPy, has about 263,000 projects. Each of these projects contains code which can empower Python programmers to build on and the shoulders of other developers to create even more complicated and powerful code. This means that if a user wants to use BCPy2000, they can use thousands of tools built into packages like NumPy, SciPy, and TensorFlow to generate, process, and display data. For example, you could use NumPy to generate a dummy signal source, write some TensorFlow machine learning algorithm, and then display all that through CyclePy. All this functionality is already implemented by other people. All we have to do is leverage it. And one of the nicest things about these projects and Python itself is that it's heavily documented and therefore easily accessible to beginners. Chances are that if you've run into a problem with CyclePy or NumPy or even a basic Python runtime error, someone has also run into that same problem, asked for a solution online, and has gotten the solution from someone else. Originally, BCPy2000 was built around VisionEgg, and at the time that was the best Python package for visual experiments. But the code hasn't been updated since 2014, so Marcus made the decision to replace it with CyclePy, and this has been the biggest area of work in the update to Python 3. The nice thing about CyclePy is that it has a really similar ethos to what BCPy2000 is built on. It's free, cross-platform, and allows you to run a wide range of tests applicable to the behavioral sciences. It's open source, which is also in line with what we are doing at the National Center for Adaptive Neurotechnologies. It has a bunch of tools and features which allow it to be lightweight and precise, and it's very accessible to a lot of neuroscientists and even undergraduate psychology students, as it has a built-in GUI builder, dynamic stimuli, and a wide range of supported hardware such as an eye tracker, buttons, and trigger systems. Another reason why we want to use CyclePy is that it's being increasingly used by neuroscientists. CyclePy is gaining popularity with neuroscientists around the world. You can see in the month of November, we've gone from 2,000 users in 2010 to nearly 27,000 users in 2019. And you might be wondering who uses CyclePy. The short answer is that almost anyone who wants to do cognitive behavioral science experiments in Python. It has a GUI and a basic editor in which you can write code and has a robust code base. This makes it accessible for almost anybody, including the typical undergraduate psychology student who generally doesn't want to be programming, while also offering the flexibility required for professional researchers to build a wide range of experiments. And right now there are over 3,400 manuscripts on Google Scholar which cite CyclePy's paper written in 2007. So now I'm going to go into what I would like to do in the near future so that it's easier to maintain and expand BCPy2000. Here we have the portable embedded Python package, which goes back to what Jeremy Hill implemented over a decade ago. Basically, this is an isolated coding space which exists in one folder where Python packages can be installed, upgraded, and used instead of packages being installed globally in your working environment. Dependencies are just packages of software that our software is dependent on in order to function. They're what enables programmers to build off the backs of previous programmers and not have to worry about reinventing the wheel. Right now, for simple use of BCPy2000, we offer a portable package that's almost anybody can download on the wiki and have it work out of the box. However, if a more skilled developer wants to make BCPy2000 work with their current installation of Python, it's very difficult for them to reproduce what we have, and if they decide that they want to update certain components at any point, there's a risk that a newer version of some dependency will change basic functionality. And my proposal for a solution to this is to offer an alternative of a portable Python environment implemented in something like pipenv or pyenv. It's similar to our portable Python package in that it's an isolated coding space where Python exists and is separate from your global Python environment, but virtual environments can be installed with a .text file or .yml file or .pip file. And this basically lists the package's names and their versions through the terminal command prompt or Anaconda prompt. When you install or upgrade a package, the old versions stay installed in your directory, so different virtual environments can utilize different package versions. This would allow us to control the Python version used and the packages installed and their respective versions. This means that we could specify a uniform, consistent way of building Python without forcing the user to use our implementation and without needing them to maintain our own distributable Python folder. Once we have completely figured out how to do this, we can empower more skilled users to have the tools to play around with how everything is implemented, while also giving the option to less skilled users who want to use BCPy2000 to simply download a link and set a path and make their own CyclePy experiment in BCPy2000. First, I'll go over our current setup, which is an entire Python environment encapsulated into a single folder. It has its own executable, its dependencies already installed, and all the tools surrounding those dependencies already in place. The major advantage of this method of Python distributables is that it's easy. All you have to do is go to the wiki or GitHub page and download the zip file, unzip it, set that path to the folder, and you're ready to go. However, this is a little bit more difficult to maintain. The first major issue with this is that Python no longer even offers a portable version of Python on their website as of 3.6.8. So if you want a portable version of any embedded Python folder, you have to rely on third-party implementations. The second problem with this is that you have to maintain both a 32-bit and 62-bit version of your packages, which have the potential to differ based on whether they're 62 or 64-bit. But the nice thing about this package is that it's going to work on most Windows installations, both 32 and 64-bit. Because we have already configured all the dependencies and matched them to work with our BCPy2000 dependency, we can be somewhat certain that it will work without much messing around. Unfortunately, this also means that it's not very flexible. It may have the potential to not work on certain OS or different configurations, and it also means that you're going to be spending a considerable amount of time debugging things. It's not simple to just add packages and play around and add new dependencies. However, with the Python environment, we really empower experienced users to get the full use out of our platform. It would allow them to easily make changes to the Python environment and add on additional functionality with a simple command in the terminal. It also allows easier maintenance. All we have to do is maintain the Python framework, which interfaces with the BCPy2000 framework, and keep one requirements file up to date with whatever version of the software package or Python installation works with our current implementation. Rather than troubleshooting an entire directory of files and dependencies and their interactions, We could specify what's needed in order for BCPy2000 to run and let developers configure it to their liking. The nice thing about pipenv is that we can specify the Python version and package version, so if any major changes were to be made, it wouldn't be immediately breaking our Python environment. However, if somebody wanted to install a newer version of a Python package or a newer version of Python, it could potentially cause problems. Another nice thing about pipenv is that it allows us to install these packages based off of your system's requirements and specifications. This makes our environment run universally compatible with whatever system we decide to run it on. So this is really a long-term project. Realistically, it would take a long-term time to re-implement many of the facets of the BCPy2000 framework in Python, but it wouldn't necessarily mean entirely re-implementing everything from scratch, because we would still have the existing BCPy2000 protocols which set the rules of how data is transmitted between modules and devices, but we would have to replicate much of the GUI and framework and operator that BCPy2000 already offers us. But I still think that for the future this is an ideal setup compared to how we're doing things right now, where the BCPy2000 framework acts as the glue between the BCPy2000 and Python. And of course, none of this would be possible without the contributions of a long line of developers. Originally, Jeremy Hill and Jason Farquhar conceptualized the integration of BCPy2000 and Python in 2004. Then master student Thomas Schreiner, supervised by Jason, succeeded in implementing it and submitting it as his diploma thesis in 2008. Jeremy Hill then further developed and maintained the project until 2009, at which point the project was left until PhD student Marcus Adamek, under the supervision of Peter Brunner, updated BCPy2000 to Python 3.6 in 2019, at which point I, under Peter Brunner, continued its development today. Thank you for listening to this presentation. You can find more information on the BCPy2000 wiki, where we have a different video demonstrating how to install, run, and modify BCPy2000, as well as some in-depth documentation.